as the angle between two concurrent forces, 5 Newton and 7 Newton, as the angle between two concurrent forces, 5 Newton and 7 Newton, increases from 0 to 180. So as the angle increases from 0 to 180 degrees, the magnitude of their resultant also changes from what to what. As the angle between two concurrent forces of 5 Newton and 7 Newton, as the angle between these forces, 5 and 7 Newton, increases from 0 to 180, the magnitude of their resultant also changes from what value to what value. Think through this and then give me an option. I'm going to take a shot and then send the question alongside the possible answers. It's an OBJ. So there are possible answers. I'm going to send it through a shot. Right? So increases from 0 to 180. The magnitude of their resultant changes from A, 0 to 35, B, 2 to 12 Newton, C, 12 to 2, D, 12 to 0. Okay, Nunya, your answer is C. Okay, we shall see. There are 3 questions, so let's quickly finish all and then we discuss. All right. Are we through? Can we discuss? Hello, can we? Josiah. Josiah. Hello, can we discuss?
Yes, please.
Okay, so the first question. As the angle between two concurrent forces of 5 and 7 increases from 0 to 180, The magnitude of their resultant also changes from yes. What are the possible answers had? Yes. Let me hear from you. Is it A 0 to 35, B 2 to 12, C 12 to 2, or D? Yes. What did we make? Erefua,
C. 12 to 2.
that is Erefua's view. Yes. The rest of you. Nunya also indicated that her answer is C. Please, do we have any different answer? Okay, Josiah. Okay. Who else? Josiah is also all right. What is my take? Now, as the angle between two concurrent forces, so the two forces are 5 and let's assume this is 5 Newton, and this is 7 Newton. Now the question is saying that as the angle changes from 0, when the angle between the forces is 0, what will be the direction of the two forces? What word will describe their direction when the angle is 0? Yes. What word will describe their direction when the angle between them is 0? Yes.
They are parallel.
So,
Thank you. So when they are parallel, the resultant is equal to what? The resultant is equal to what?
F1 plus F2.
Okay, so a summation of all of them. So 5 plus 7. This is when the angle between them is 0. So we have a resultant of 12 Newton. Now, if they are 180 degrees apart, then the two forces are as drawn. They are oppositely directed to one another. And in this case, what will be the resultant? How do we obtain the resultant? In this case, how do we obtain the resultant?
7 minus 5.
So is the difference between them. You subtract the smaller one from the larger one. So 7 minus 5. So the angle, their magnitude would change from 12 Newton to 2. And so the option C is correct. Okay. A very, very intelligent question. Question 2. As the vector sum of all the forces acting on a moving body increases, as the vector sum of all the forces acting on a moving body increases, the acceleration of the object A decreases, B
Yeah, I have assignments.
increases, C both increases and
Michael,
decreases.
remind me that 4 o'clock, no matter what time we have to understand.
Gabriel, mute yourself. Okay, so as the vector sum of all the forces acting on a moving body increases, the acceleration of the object, will it increase, decrease, both increase and decrease, or remains the same? Yes. As the vector sum of all the forces acting on a moving body, okay, increases, what will happen to the acceleration of the body? Yes. Anybody? as forces acting on a body increases, what happens to the acceleration of the body?
It will increase.
It would increase. Well, let's why? Why will it increase?
Sir, please, because of the forces acting on it.
So there is a relation. You see, Newton's one of the Newton's second law of motion says that force on an accelerating body is given by mass times acceleration. Meaning that the acceleration of a body is equal to F over M. From this relation, we can prove that, or we can deduce that, then acceleration is directly proportional to force. And the same acceleration is inversely proportional to mass. So for an accelerating body, when the force increases, the acceleration also increases. And when the mass increases, acceleration decreases. So once the force, the vector sum of the forces acting on the body is increasing, the acceleration would also increase by this relation. Is that okay? All right, and then 3. A 6 Newton force and 8 Newton force act concurrently on a box located on a frictionless horizontal surface. Act on a box located on a frictionless horizontal surface. Which top view diagram shows the force producing the smallest magnitude of acceleration of the box? Which top view diagram shows the forces producing the smallest magnitude of acceleration of the box? Yes. Which of the 4 diagrams would produce the smallest magnitude of acceleration of the box? Is it A? Is it B? Is it C? Or D? Yes. Yes, views. Share your answers with me. Yes. Jojo, Erefua, Dela, which of the 4 diagrams here would produce the smallest acceleration? I've just told you, connect it this way. I just told you that acceleration of a body is directly proportional to the force. And class, when 2 quantities are directly proportional, what does it mean? If 2 quantities are directly proportional, what does it mean? Yes. Dela, tell me what it means. When 2 quantities are directly proportional, what does it mean? Dela, Paulette, Erefua, Jojo, Dodu. There's a hand up. Go ahead. Please, if your hand is up, go ahead.
Sir,
Yeah, go
please,
ahead.
when 2 quantities are directly proportional, that means they affect each other. When one increases, the other one will increase. When one decreases, the other one will decrease.
Exactly. So a typical example is acceleration and force. Okay. Imagine yourself sitting on this wheel bicycle and being pushed. What will be the nature of your speed? When one person pushes you, you are on a bike, and one person pushes you. Then when two people pushes you, when three. So the more the force, the larger will be the acceleration. So when two quantities are directly proportional, an increase in one would result in an increase in the other. Now, when two quantities are inversely proportional, what does it mean? Two quantities are inversely proportional.
It means that an increase in one of them is a decrease to the other.
Yes. When one increases, the other one will decrease. Okay. And when one decreases, the other would also increase. So a clear relationship is acceleration and mass. Imagine the same force acting on the same bicycle scenario I created. But this time there are two people. One, a very fat person. So fat, like Wisteria, very, very fat. And then another skinny, slim person. Like who? Wisteria again. But here, I'm looking at one person being fat and the other person being slim. And the same push. Okay, so two same bikes. On the bike, we have a fat person. On another bike, we have a small person. And the push given to each one of them is equal. How would you describe the speed that would happen in each of the two examples? How would the speed be? Yes. I want somebody to share your view with us. So mass one, we have mass one and then mass two. Mass one is greater than mass two. We have the same force acting on all of them. What will be the acceleration of them? Yes, anybody? Okay, Erefua.
Please, the acceleration of mass 1 will be greater than the acceleration of.
Let's use the fat person and then the slim person here. So the same bike. There is a fat person, there is a slim person. Each of them is being pushed by the same force. How would 1 and 2 accelerate? Yes. There's another. Okay, Gabriel.
Okay, so.
Okay, Rafa, go ahead.
Okay, please, the speed of the slimmer person will be greater than the speed of the fat person.
Exactly. So the acceleration in the slim person will be greater than the acceleration of the fat person because, and this is proven by this relation, A is inversely proportional to mass. The greater the mass, the smaller will be the acceleration. The lesser the mass, the greater will be the acceleration. And so when two quantities are inversely proportional, an increase in one results in a decrease in the other. A decrease in one is an increase. Another example is density and volume. Density is equal to mass over volume. It means that density is directly proportional to mass. And the same density is inversely proportional to the volume. Okay. So back to the question. Which we have 6 Newton and 8 Newton force acting on a body, on a box. Which top view diagram shows the forces producing the smallest acceleration of the box? Yes. What is the correct answer? Which top view would produce the smallest acceleration of the box? Benedicta. Eurefua. Okay, Nunya is giving us D. Nunya, why? I always would want the explanation. Why do you think D will be the correct answer? Can somebody explain to us so we can move on? Give us an answer and explain why you think so. Della, speak. Angel, speak. Della, give us your answer and explain.
Mm,
Della, I'm listening. I hate silent people. I hate quiet people. Angel, Jojo, what do you think? Yes.
Me too. I feel like it will be D.
Why?
Because the forces are kind of opposing each other in somewhat, because one is pulling one way, the other one is pulling that way. So I feel like there'll be less magnitude of acceleration on that box.
Good. So the answer is D, because D would give us the smallest resultant force. If we are to calculate the resultant force of all, see, A is at an angle. The two forces are at an angle. Let's assume the angle is even acute, 30. The resultant force would be, we have to use cosine rule. So 6 squared plus 8 squared plus 2 times 6 times 8 cos of 30. The angle is not there, but I'm assuming theta is 30 degrees. So we have 36 plus 64 plus 2 by 6 by 8 cos 30 is root of 3 on 2. So we have 100. This is 100 plus, yes, that's 6 by 48 root of 3. So what's the final answer? 48 times root 3 plus 100. Yes, let's hurry up. Let's hurry up. What's the answer?
183.138.
Okay.
100 plus 48 root 3.
So this is 183 points.
138.
Okay, let's pick 14. Therefore, R will be equal to square root of 183.14. Yes, what's the answer? Square root of that. Because of you people who have gone to buy a calculator, because your responses delayed for me. I'm not happy with that at all. So this is the answer. So if for A, if the angle is 30, anything acute, that's it. Now, let's find the resultant for B. And B, what is the angle between them? For B, what's the angle between the forces?
90 degrees.
90. So let's find the resultant quickly. Let's find the resultant. We have to use Pythagoras theorem. F1 squared plus F2 squared. So R will be equal to square root of 6 squared plus 8 squared. That is 6 plus 64. The answer is 10 Newton. Then D. For D, what will be the resultant? For D, what will be the resultant? Let's hurry up. Oh,
2
D.
Newton. 2 Newton.
Sorry, come again. Look at it again. For is it D? Sorry. Okay, you are right. So D is 2. And I'm sorry. Then C. What will be the resultant for C? C. Let's hurry up with our responses.
14.
14.
14. So when you look at it, this one seems to give us the least resultant force. And since acceleration is directly proportional to the force, okay, then this one will give us the least acceleration because it is producing the least resultant force. That is the solution. That is the solution. Okay, a last question. And I must ask this before, a very simple question, but I want to see how you can apply. So we have this. Listen to the question. Let me take a shot and drop it on the platform so you can also think through. So let me trim it a little bit. We have these two vectors. Vector 1 and this vector 2. Then we have A, B, C, and D. Which of the vectors A, B, C, and D represents the resultant of this? Which vector best represents the resultant of the concurrent forces A and B? Okay, so here instead of A and B, we'll make it 1 and 2. So which of the odds A, B, C to D represents the resultant of these two vectors acting concurrently at this point? Yes. If your answer is ready, share with us. from A to D, okay, from A to D, which of them will represent the resultant of these two vectors? Erefua Angel.
B.
Who says
B.
Who says B? Who is saying so? Adam. Okay. Isaac Atta, B. More views. Paulette, B.
B.
Okay. All right. Let me also. Yasmin, you are not talking. What do you think?
Yes, I also
Angel, you are-
think it's B.
Okay. All right. Let's see what I also think. What do I think? So to get the resultant, I need to realign the direction of the forces because as it stands, they don't have a common locus or direction. How do I do it? By Jojo, what do you think? Jojo, what do you think? Jojo is not even around. So I need to realign their direction using equal vectors. So I create equal vector of 2 and put on the head of 1. Equal vectors must have the same magnitude and direction. So this is 2. I do same for for 1. Now after doing that, oh, okay, this is here, this is here. Oh, okay, then a vector drawn from the tail of this to the head of 1 will represent. So I look at what I have and, oh, okay. So if you look at the possible answers here, B resembles this one. So thank you so much for your wonderful contributions. You are spot on. Thank you. All right. So if I have, so as I said, the cosine rule, the sine rule is only limited to 2 forces acting concurrently at the same point. If I have 3, if I have 4, how do I determine the resultant? To help us, let's quickly look at resolution of forces into components. Resolution of vectors. Vectors. Let me make it. Into components. Okay. Now, a single vector can be resolved into 2 components. Hello, can you hear? Can you hear me?
Yes, please.
All
Yes,
right.
please.
A single vector can be resolved into 2 components. A single vector quantity can be resolved into two components. What do I mean by a single vector can be resolved into two components? Let's draw the Cartesian plane x and y. So this is the y-axis, positive. This is the y negative. Positive x, negative x. If I have a vector quantity and it lies along either the x or the y axis, it has one component. I'm coming in. So if I have a vector component, be it a force, velocity, or acceleration, and it is along the x-axis, the vector is along the x-axis, maybe a force. The force has magnitude. I want to change my marker. They are not clear as how I want. I'm coming. So the vector F is along the x-axis. F Newton. Another one is along, maybe this is F1. F2 is also along the positive y-axis, F2 Newton. Now, because if I'm to resolve this into components, okay, what I'm doing is that I'm looking for its x component and its y component. Now, the fact that it is along the F, along the x means that it has x component of F1 and y component of 0 Newton. And this is similar to your transformation lesson. If you are given a point and the point is on the x-axis, if you are asked to represent this point A into components, you say that this is the x component is equal to A, the y component is equal to 0. In the same way, if the point is a point B along the y, resolve this into component, you say that the x component is 0, but the y component is B. Please, are you following? Are you following?
Sir, please come again.
Yes.
So what I'm saying is that this is similar to your JHS transformation, where if you have a point within the Cartesian plane, your x and y, like this, y, x. If you have something like this and you are given a point B, a point A here, and a point B, express this point, okay, into component, coordinates. This point A is equal to A and y component of what? 0. This point B is equal to, instead of A, let me represent this by x. this point B is equal to x component of 0, but y component of what? Y. If the point is here, maybe C, and you are asked to express the point C in coordinates, you realize that the x component will be equal to whatever is here. But this is negative x. So you say that x will be minus x and y will be equal to, you read it from here, also minus y. Please, are you okay here? Are you okay with the explanation? Are we okay?
Yes, please.
So what I'm saying is that assuming you are given a force and the force lies on this axis, it's directed here, F. If you are asked to resolve this into component, it has a vertical component of F, sorry, a horizontal component of F and a vertical component of 0. This F2 would also have a horizontal component of 0 and then a vertical component of F2. This is what it means. So it is as if a vector lies on either X or Y, it only has one component. The other one is 0. That is what I'm driving at. It's similar to you standing and then being asked that, what is your height along the ground? You have 0 height along the ground, but your height vertically is your real height. So along the ground, your height is 0, and then vertically, your height is whatever height you have. Now, if you lie on the ground, assuming you are lying flat on the ground, then you are asked, what is your vertical height? Once you are lying on the ground, your vertical height is 0, but your horizontal height is your height that is on the ground. Please, are you okay? Are you okay? Good. So, if a vector quantity, a single vector quantity can be resolved into 2 components. But if the vector quantity lies along the x-axis or the y-axis, it will only have one component. Now, if it lies on the y-axis, then it means that it has an angle of 0 degrees to the y-axis. So, I have this vector. F1 lies on the vertical. The fact that it lies on the vertical means that it makes an angle of 0 degrees with the y-axis. So this F1 makes an angle of 0 degrees with the y-axis or with the north. If I have another one, maybe F2, and it lies along the x-axis, this is y-axis, this is x. It means that F2 makes an angle of 90 degrees 90 degrees from the y-axis, or from the north. And this is because bearings are always measured from the north. For bearings and vectors, the angular measurement is always taken from the north. For bearings and vectors, angular measurement is always from the north. It's always taken from the north. So for vectors and bearings, we are always measuring our angle from the north. That is why we are saying that F1 will be 0 degrees with the y-axis, but F2 would be 90 degrees, okay, from the y-axis. So if a force lies on X, it makes an angle of 90 degrees because we are always measuring our angle from the north for bearings and vectors. Please, are you okay? Are you okay?
Yes, please.
Sir, please, can you come again on the bearing part?
What I'm saying is that today my voice has lost its quality. What I'm saying is that for vectors and bearings, we are always taking our angular measurements from the north. Okay, so this is different from trigonometry. Trigonometry is about measurement of triangles. So in your angle, okay, whenever you are taking an angle, you measure your angle anti-clockwise. Okay, if there's the line, and then the line is here, and you have to measure this angle. In trigonometry, you are always measuring your angle anti-clockwise. But for bearings and vectors, angular measurement is always taken from the north. So if I'm giving a force and it makes an angle of 30 degrees, the angle it makes with the vertical is 30 degrees. This is how I'll determine it. First, I need to draw my north, either the cardinal point, north, south, east, west, which is the same as YY, and measure my angle from the north. So from the north, I measure an angle of 30 degrees from there. And this will be the direction of the force. So for bearings and vectors, angular measurement is always taken from the north. Please, any question? Any question? All right. So if I'm given a force, F, Isaac, I thought you were asking, you are going to ask a question. Okay. I'm giving a force F. The force F makes an angle of theta degrees with the vertical. I'm asked to resolve this force, resolve F into components. don't forget that I said earlier, when the force is along the Y, north, south, west, east axis, it only has one component. But the moment it is in between, it will have two components. Okay, so I'm going to look for its vertical component and then the horizontal component. Okay. Now, if this is theta, then the angle between this, the force and the east would also be 90 minus theta. Example, if this is 30, then this will also be 60. Please, are we okay? Are we okay?
Yes, please.
Meaning, I can resolve this, the force F into component, using any of these two angles. Okay. We are going to use both to see how it's going to be. And I'm using the angle it makes with the x-axis first, which is 90 minus theta. To resolve F into component, I'll need the vertical component and then also need the horizontal component. The two must be equal, must be perpendicular to each other. So first, I'm using the angle 90 minus theta. Now, in trigonometry, whenever you take the sign, there are, okay, let me treat it as if I'm teaching trig ratios. If you have a right angle triangle, you have an angle theta. The opposite is perpendicular to the adjacent. Whenever you are looking for, assuming this is C, the hypotenuse is C, the opposite is A, and the adjacent is B. From Pythagoras theorem, C squared, the square of this, the hypotenuse, is equal to the sum of the squares of the other two sides. So A squared plus B squared. We've learned this. This is not new to us. We also have trig ratios. The trig ratios are a ratio of the three sides. A is known as the opposite side of the right angle triangle. B is known as the adjacent. In fact, the adjacent is also known as the horizontal. And then the opposite is also known as the vertical. So either I talk about opposite or vertical, or adjacent or horizontal. Vertical. And then C is the hypotenuse. This angle is known as the angle of elevation. If you are standing on the ground, if there is maybe a tree or a flag, and Jojo, you are here, you are on the ground, and you want to look at the flag, the angle through which you need to turn your eye to view the flag, okay, you will raise your eye or elevate your eye. So this angle through which the eye has to be raised to view an object up is known as angle of elevation. So this angle theta is known as angle of elevation. To elevate means to raise, or angle of inclination, or angle of inclination. So either you call this angle through which the eye level has to be raised to view an object up, angle of elevation or inclination. And if you are at the top, you are here. This time you are standing here. Maybe a bird was here and Eva or Angel was looking at the bird. Angel needs to elevate the eye through this. The bird, to see Angel or Eva, would have to lower its eyes, depress, lower the eye through this angle to see Angel. And this angle through which the eye level must be depressed or lowered to see an object down is known as angle of depression. So alpha is known as angle of depression. Please, are you there?
Yes, please.
And in fact, theta and alpha are the same because they alternate. So if this is 60, this will also be 60. All right. So we will call this angle of elevation, theta. Once you identify the angle, or we note the angle, then this is theta. The side of the right angle triangle, which is opposite to the angle, becomes the opposite. So this is the angle. This side is opposite to it. So A becomes the opposite. If the angle is changed, or this time we are talking about this angle, maybe alpha. So for theta, A is the opposite. Now for alpha, the side which is opposite to alpha is this side. So for alpha, B is the opposite. So the opposite side has to do with the angle. It is not a fixed situation. The opposite side of the right angle triangle, okay, has to do with the angle. It isn't always fixed. It depends on the angle position. Are we fine?
Yes.
Yes, please.
All right. So it depends on the angle. It depends on the angle we are talking about. So for theta, A is the opposite. And for alpha, B is the opposite. Okay. The hypotenuse is always the longest side. So that can easily be identified. Usually, the problem area is the opposite. Okay. So let's use that to look at the trig ratios. There are three main trigonometric ratios. We call it trigonometric ratios, trigonometric ratios. In fact, trigonometry means measurement of triangles. That's the meaning of trigonometry. We have three main trig ratios. Basic trig ratios. We have what we call sine, shortened as SIN. Don't mention sin. No. We also have cosine, shortened as cos. We have tangent, shortened as tan. They are all applied to the angle. So, if I'm to find the trig ratios of this angle, theta and alpha, sine theta, the sine, the cosine, the tangent goes with angle. So you can't just say sine. Sine what? What's the angle? Sine 30 degrees, 40 degrees, 60. So they are mentioned with angles, not just sine and you are signing. No. Okay. So sine theta. When we talk about sine, is the ratio of the opposite side of the right angle triangle over hypotenuse. And this, to help easy memorization, we pick the S of the sine, O of the opposite, H of the hypotenuse, then create a word or mnemonics with it that for sine it's so. So at the mention of so, you will be sewing. So the S means sine, the O means opposite, and the H means hypotenuse. So whenever you mention so, it is the trig ratio sine, which is opposite over hypotenuse. Please, are you okay?
Yes, please.
Yes, please.
Then we have cosine, cos. I said this trig ratios goes with angle. They don't go in just in isolation. So cos of the angle theta or alpha, depending on the angle of interest. Cosine is a ratio of the adjacent side to the hypotenuse. So for easy recall, we pick the C Josiah, please mute yourself for me. Josiah. Okay, so for easy, memory, we pick the C, we pick the A, then we pick the H. K. Okay, so at the mention of K, the C is cosine. Come in here. Desire me bebo. All right, so at the mention of this, the C is cosine, A adjacent, H hypotenuse. Then lastly, we have tangent. Tangent. Tan of the angle theta. The trig ratio tangent is a ratio of the opposite side to the adjacent. So for easy memorization, we pick the T, O and A, toi. So when you join the three, you have so, ka, toi. And class, this is what helped some of us to memorize this thing so well. Whenever it is asked and you can't figure out which one is the ratio one, so katwa, so means opposite hypotenuse, ka is cosine, adjacent over hypotenuse, toa, tangent, opposite, and it helped us so well. So we have created beautiful word with their initials, which will aid easy memorization of the trig ratios. So I recommend it to you to also use to master this technique so well. Is that okay?
Yes, please.
All right. So if maybe I want to get the components. I have a right angle triangle. Please, any question? Because I'm going to clean the SOHCAHTOA. I have this right angle triangle. I need the opposite side. I need adjacent. Yes, au revoir.
Mr. India, please, I wanted to ask that the angles, can it be any angle at all, or it has to be compulsorily the angle where you are asked to find? Or maybe the angle like, you see, you said we have to use theta for all of them. So can you like use alpha if maybe
Oh,
what
yeah.
you are finding demands you to find alpha?
Oh, yes. You see, I didn't use only theta. This is theta. This is also alpha. So we are going to apply, okay. As for this, it's a right angle triangle. So this is 90. Okay. So if I have the opposite side, okay, this is to this angle, A is the opposite. Then to alpha, B is the opposite. So C. So if I'm to determine the trig ratios for the angle theta. So for angle theta, the trig ratios, tan of the angle theta. I know tan is opposite toi. Tan is toi. Opposite over adjacent. Which angle are we talking about here? We are talking about theta. So for theta, this side is the opposite. This side is the adjacent. And the longer side of the right angle triangle becomes the hypotenuse. So tan theta would be equal to opposite side, which is A, over adjacent, which is B. For theta, the sine of the angle theta would be equal to, what is sine? Sine is so opposite over hypotenuse. So
Hypotenuse.
So A over C. Cosine of the angle theta. Cosine is K. Adjacent over hypotenuse. So what is the adjacent? B over hypotenuse C. So I have identified all the trig ratios for the angle theta. Let's do it for alpha. For angle alpha, help me derive tan of the angle. So tan alpha, yes. Help me obtain expression for tangent of alpha. The angle alpha.
Sir,
Yes.
B over C.
Thank you. B, come again.
B over A.
So please
Over
tangent to opposite over adjacent. So B over A. Now sine alpha. Sine alpha.
B over C.
B over C. Thank you. B over C. Then cos alpha. Cos alpha.
A C.
Pardon? Hello.
A over.
So A over
C.
C. Now look at, let's compare this to this. We can see some similarities. We can see some similarities. We can deduce that sine theta is equal to cos alpha. Sine theta is equal to cos alpha. And they are all equal to A over C. We can also identify that cos theta is also equal to sine alpha. And they are all B over C. There is a special link. Let's use values or numbers. Assuming this is 30 degrees. Once this is a right angle triangle, what will be the other remaining angle? What will be the other remaining
70
angle?
degrees.
No, open your eyes.
60 degrees.
It will be 60. Once this is 90, this must also sum up to be 92 to total 180. Because sum of angles in a triangle is equal to 180. So if you have, okay, so that's how to identify that easily. Okay, so this is 60. If that is 60, okay, for isosceles triangle with size 2 units, assuming this is an isosceles triangle, equal size, each side is 2. The perpendicular line divides the base into 2 equal parts. So if this divides this base, then B would be 1. This side would also be 1. Okay. Assuming we are using triangle A, B, C, D. So we are restricting ourselves to the right angle triangle ACD. ACD. So it's like looking at this triangle. Now, if this side is 2, this side is 2, what will be the opposite side? Yes. If we have this side to be 2, this side to be 1, what will be the opposite side? This is similar to cleaning this. It's like we are cutting out this. So we have a certain right angle triangle. The opposite side is 2. This side is 1. What will be this opposite to the angle 30? Yes. Yes. Quick one. We'll be in your trick, you know. Colette, I will find Jojo. What will be the side AC?
3.
No. No. Jojo. Della. Yasmin.
1.7.
1.7, bang. Okay, leave it in whole number. I don't want it in decimal.
I also think it's 3.
You said it's what? 3. Did you say 3?
I said I also think it's 3.
No, I won't buy it.
Please, can I get the question? I
Please,
got
I
so.
think it's 0.0349.
I don't want decimals. You can leave your answer in sets, but I don't
Please,
want
can you
decimal.
say?
So the root of 3.
It's root of 3. How did you get it? How did you get root 3? What method did you use? One word.
Pythagoras theorem.
Pythagoras theorem. Okay. So if the hypotenuse is 2, so we have 2 squared must be equal to 1 squared plus, we don't know the opposite. If it's AC squared. Then find AC. You have AC squared equal to 4 minus 1. And you didn't square. Therefore, AC is equal to root of 3. Root 3. You see, when we started vectors, angles such as 60 degrees, 30 degrees, 45 degrees, I can easily tell you their values without punching the calculator. This is the trick. If you pick an isosceles triangle, 2 units, and then because this divides the base into 2 equal part 1, then you chop off the other one and determine the opposite. Now, if I want 30 degrees, sine 30. Sine is so opposite over hypotenuse. So root of 3 is the opposite over 2. Punch it on the calculator. Oh, sorry. I get you. This, for an isosceles triangle, this will rather be for equilateral triangle, this will be 60, this will be 30, because an equilateral triangle has equal size and equal interior angles. So each interior angle must be 60. Let me bring the other parts for you to understand. So it's like this. This side is 2, this side is also 1, but it's an equilateral triangle, equal interior angles as well. So this side must be 60, this side must also be 60. If this is 30, this will also be 30. But we are always using one side for our analysis. So we sort of chop off the other side to use the right angle triangle. So if I have this and I'm looking at sine 60, which is opposite over hypotenuse, root of 3 over 2, cos 60. Cos 60 is adjacent over hypotenuse, half. Then let's come to the 30. Sine 30. For the angle 30, this time, this side is the opposite. This is the hypotenuse, and so this will be the adjacent. So sine 30 would be 1 on 2, half. cos 30 cos 30 adjacent over hypotenuse root 3 on 2. If I'm looking for tan 30, tan is opposite over adjacent. So 1 on root of 3, which is also equal to root 3 on 3. If I want for 60, tan 60, for 60, there's the opposite, there's the adjacent. So when you understand this, if I need those values, I can tell you without using calculator. So that's the trick. I have learned it, okay, over the years. So if I have to calculate for 60, I know it's half. You would punch it from the calculator before. If I want sine 60, I know it's root 3 on 2. Sine 30 is half. It is just because I have mastered and have used this over the years. So that is the trick. Okay. So I'll do this sometimes to master it. I'll try and then draw the right angle triangle in the sky. Draw an equilateral triangle with 2 unit size each. Then draw a perpendicular line which divides the base into 2 equal parts, 1, 1. Okay, because it's an equilateral triangle, equal interior angles. So 60, 60, and I know the perpendicular bisector would make it 30, 30. So 60, 60 here, 60 there, and 30 up. Then I clean one side. Because there are 2 units each. This is 2. This side must also be 2. Then this is 1, 1. Clean the other side and use it with the knowledge of trigonometry. Use it for my analysis. You can always, when you do that, you can master by even closing your eye when you are caught. And try it. I want you to try it. Please, is that okay? Try it so that we all use it. Am I talking to people?
Yes, please.
Yes,
Good.
please.
Yes, please.
So that is how to resolve forces into components. So if I'm given an angle, let's go back to I'm taking you through the foundation. And so what I'm actually doing has been delayed. We have this right angle triangle. This is theta. So this is 90 minus theta. I'm to resolve the force F into components, 8 vertical components and 8 horizontal components. This is a right angle triangle. What I know or what I have about the right angle triangle is the force, the hypotenuse, and then the angle of inclination. I need to use that to find the vertical and horizontal component. Now, if you have hypotenuse and the angle, and you are looking for opposite, which appropriate trig ratio would you use? If you have the hypotenuse of the right angle triangle and then the angle of elevation, and you are looking for opposite, which appropriate trig ratio would you use? Will you use tangent, sine, or cosine?
Cos theta.
Please sign.
It says sine.
Okay, I take the question again. I have, for a right angle triangle, I have the hypotenuse. I have the angle of elevation, and I'm to look for the opposite. Obviously, the appropriate trig ratio is sine, because sine is so opposite over hypotenuse. Okay, so sine of the angle, what is the angle? 90 minus theta is equal to the opposite side, which is being looked for, divided by the hypotenuse, which is the force F. The unknown is therefore equal to F times sine of 90 minus theta. So this is the vertical component of the force F. So I'll call this as F vertical. Now I need the horizontal component or the adjacent. Which appropriate trig ratio do we use? Yes. For which appropriate trig ratio do we use to determine the horizontal?
Sine. Cos.
Cosine. Okay.
Cos.
So if I take the cosine of the angle, we are using this 90 minus theta. We have the adjacent, because cos is adjacent over hypotenuse. I don't know the adjacent over the hypotenuse is F. The unknown made as the subject, I have F cos 90 minus theta. This unknown, I'll call it as F horizontal, because it's the adjacent or the horizontal component. Please, it's a subscript, it's down there. So F horizontal is equal to F cos 90 minus theta. So it means I have resolved the force F into its vertical and horizontal form. And this is equal to F, the X is the horizontal, F cos 90 minus theta and F sine 90 minus theta. So these are the components of the force F. Horizontal and vertical component of the force F. Now, I can do the same thing and get the same value or answer using the other angle theta. So what 90 minus theta can do the same thing, and you have the same result. So if I want to use theta, then for this angle, for theta, this side becomes the opposite. So this will be F will it be F vertical or F horizontal? For the angle theta, this side becomes the opposite. And this side becomes the adjacent. Now for this side to the angle, will it be F vertical or F horizontal?
F vertical. Vertical.
Okay. Now, Dodo, because this is the opposite of the force of the angle theta, you see, you are calling it vertical, but it is it is within this component. It is within the x component. Okay, don't forget this side. This side became horizontal, or fx. 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 This side is fx. So instead of having this here fy, fh, let's make it fx. Fx because it is within the x-axis. And so it will bear the same thing. So this is also fx because we can read this from the x-axis. To the angle, this is the horizontal. But because it's along the y-axis, we call this as fy. So this is for using the angle 90 minus theta. This side is fx, horizontal, meaning this side too is fy, the vertical. Now to the angle theta, this is the opposite, but because it lies within the x-axis, we also call it fx. And this is the horizontal, but it lies, it can be read within the vertical y-axis. So fy. Please, are you okay? Are you okay?
Now, please can you come again on the last?
You see, we are using two angles. 90 theta and 90 minus theta. To the angle theta, this side is the opposite. So it is true when Joe just said F vertical. Okay, but because this side, if you are reading it, assuming I have values here, maybe 1, 2, 3, 4, you read this length from the numbering here. Okay, so this side is the same as this side. So if we are calling this horizontal or x, this must also be x. That's what I mean. Now, this side is the adjacent to this angle, but it lies within the y-axis. It can be read from the y-axis. So this side will also be y, okay, fy, just as we had this here. That's what I'm saying. So if we take sine of theta, sine theta, we are using the angle theta. What do you think will be sine theta with regards to the angle theta? What will be sine theta with regards to the small angle theta? Sine is opposite. So opposite, okay, opposite, which is this, fx over hypotenuse, which is f. Therefore, if you make fx the subject, you have f sine theta. And this is, okay, this is what we will call as the horizontal component, or fx. Now, if I need the vertical, which is y, I take cos of theta. I'll use real numbers when I finish. And cos theta is the adjacent, which is fy over f. If you make f the fy the subject, you have fy is equal to f cos of theta. Now, with the angle theta, x and y components would become f sine theta and f cos theta. Now the difference is that when we were using the angle to the x-axis, it was cos sine. It was cos sine. When you use the angle the force made to the y-axis, it changes to be sine cos, but the value is the same. Please, let's use real numbers. Let's use numbers to help our understanding. So I have a force of 100 Newton. So I have a force of 100 Newton. This is the north, this is east. The same as y and x. This force makes an angle of 60 degrees from the north. So I have 100 Newton, 60 degrees. The angle it makes with the, let me draw the 60. It should be larger, a bit larger than. The angle it makes with the x-axis is 30. Now, my task is to resolve this force. Resolve this force into components. My task is to resolve this force, 100 Newton, into components. So what the question seeks to find is to have the vertical component and then the horizontal component of this force. Okay, so how do I do it? The vertical component must be perpendicular to the horizontal component. So F Y is a force, so there should be direction. It will obey triangle law of vectors. So this plus this is equal to this. Now, I can use any of these two angles to have the components. So if I take cos of 30 degrees, this is fx. Because if I want the x component, the appropriate trig ratio is cosine. So cos 30 will be equal to fx divided by 100. Fx is equal to 100 times cos of 30. And because cos 30 is root 3 on 2, I have 100 times root of 3 on 2, which is equal to 50 root 3. I just want to leave my answer in sets. So I found the horizontal component. Let's come to vertical. I must use the appropriate trig ratio to use a sine. So sine 30 would be equal to the vertical component, which is Fy over the hypotenuse, which is 100. Fy is equal to 100 times sine 30 degrees. Sine 30 degrees is equal to half. So I have 100 times half, and that would be equal to 50 Newton. Now I want to confirm that The other angle would also give me the same thing. So I want to use the other angle to test for my results. Are we there? Hello, are you there?
Yes, please. Yes.
Okay, so I want to use 60, the angle 60 degrees. But to the angle 60 degrees, this side will be the adjacent and this side is the opposite. They must also obey the triangle law of vectors. So if I take sine of 60, this is the opposite, which falls under within the x-axis. So this is also fx. So sine 60 would be equal to the opposite, which is fx over hypotenuse 100. Fx is equal to 100 times sine 60. Sine 60 is root 3 on 2. So 100 times root 3 on 2. I have 50 root of 3 Newton. The same value as what I had for Fx. The same value. Now, this component, the vertical component here, cos of 60 is equal to adjacent, which is Fy on 100. Fy is equal to 100 times cos of 60 degrees. Well, 60 is half. So I have 50 Newton. Therefore, whichever angle that is used, you have the component X and Y component of the force F or of the force 100 Newton to be equal to 50 root of 3 and 50 root 3 Newton and 50 Newton itself. These are the components of the force, 100 Newton. Please, I hope it is understood.
Yes, please.
So it doesn't matter which of the angles to use. You have the same results if you understand what it is being done. So, in fact, within the weekend, I will shower you with examples to try your hands on. That's okay. Is that okay?
Yes, please.
Yes, please.
Okay. So if you have any question, ask. If you have any question, ask. If you don't have any question, then this is where I draw the curtains on our meeting today. Thanks for your time and everything. Please watch the videos and subscribe. I haven't had enough subscription from my very people, and it is worrying. So please go and watch Jojo and go at them. Leonard, go and subscribe, watch and subscribe so that I have more followers. Okay. Lizzie, Angel, Yasmin, Paulette, and the rest of you, to all those whose name were not mentioned. In fact, I can't recall all the names. I would have loved to. All right, so do so for me until Tuesday. In fact, may God be with you. Have a blessful weekend. Okay.
You too.
You
Thank
too.
you.
Amen. And you too.
All right. Bye-bye. All right.
Bye.
All right. Leonard. Okay. You have declared it. Okay, bye-bye.